The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Welcome back. And for those of you joining for the first time, welcome. This is our series of Raritan PowerTips, where we share some of the capabilities that we have in the products that you already own and use. And we wanted to take this opportunity to get everybody together and share those tips and tricks with you. My name is Jawahar. As you see, I'm streaming live from Paradise, or pretend Paradise, from my own little home office. As many of you are facing the same kind of situation, we're trying to make things work, and here's one of our efforts to make this work better. So this is a 5-part series. We started last week. This is week 2, and we have 3 more weeks to go for the Raritan ones. And we also have a server tech series that happens on Thursdays, starting last Thursday. We have the next one tomorrow. And to talk about today's session, I'm going to turn it over to Joel Bryan, who's the head of our tech support team within Legrand DPC, and he's going to walk us through today's topic and the presenter. Joel?
Okay, thank you, Javi. Thank you, Javi. As Jawahar says, my name is Joel Bryan, and I'm the Global Director of Post-Sale Support Documentation and Services here at Legrand for the ServerTech and the Raritan brands. So today's session 2, is focused on how to make sure we're not overloading our phases within a PDU. We all know that this is important, that we have our phases that are balanced at the PDU level and also upstream as well. So we want to make sure that you guys understand how to check for that and how to properly adjust the loads to make sure that they are indeed balanced and aligned with your goals. So walking us through today's session is Duncan Gwynn, and he's our post-sale support specialist, part of our tech support team and organization here. And following the walkthrough, as Jawahar said, we will open up for questions pertaining to this particular feature. In addition, please feel free to add comments as we go along, and we will try to incorporate those towards the end or try to answer as best as we can. And as usual, for any pressing issues outside of this, it's best to definitely email us at tech@raritan.com, or if you need a live person, just pick up the phone and give us a call. We're here. We're still working to support you guys and support all of our customers out in the field. So with that, I'm going to hand it over to Duncan, and following that, we'll open it up for questions. Okay? Thank you. Duncan, it's on you.
All right. Thanks, Joel. Thanks, Jawahar. As mentioned, today's session is how to avoid overloading phases in a 3-phase PDU. So one of the tools that we have available for you is actually located on our blog. This is a blog post that was posted many years ago, 2011. And it's continues to be one of our most popular blog posts because of this 3-phase calculator that's available. So I'm going to go ahead and download this calculator. We'll dive in and have a look at it. So the first tab of the 3-phase calculator here is just in a simple instruction sheet, guiding you on, selecting the right PDU, and making sure that, you're choosing it carefully. What we're going to look at today is the third tab here, this 30 amp PDU. And you'll see this is a 208 volt line-to-line PDU. It's a 30 amp PDU, and the rating is 24 amps, derated 80%, as all of you know. You'll see that we have our 3 phases here. So we've got our L1, L2, L2, L3, and our L3, L1. And then off to the side, you'll see our input voltage. Now, this can be adjusted as needed, but we have it at the suspected voltage of 208. And then the power factor can be edited as well. And obviously, this is an ideal value of 97.5. If you have some actual values of your power factor based on historical data, feel free to plug that in and plan accordingly, because that will have a large effect on how this calculator works. So down below, you'll see the individual line currents. So we've got our L1, L2, and L3, and these cannot exceed the 24 amp rating. And then the total power of the PDU is rated at 8.6 kVA. Now, if you are, planning, a new rack, I assume that you're probably using redundant power and you have an A feed and a B feed. In that case, you could either use this calculator and cut this rating in half and use it as a 4.3 kVA and try not to exceed that, or you could use the calculator as if you were in a failover state and all of your connected devices are pulling power from this one PDU, in which case you wouldn't obviously want to exceed that 8.6 kVA rating. You can see the various outlets here. Obviously, your PDU probably doesn't have this many outlets on each phase, but we wanted to give some flexibility and allow you to be able to plug in multiple devices to kind of see how that moves around. You've got C13 outlets, which can't exceed the 12 amp rating, and then the C19 outlets below can't exceed the 16 amps. As far as the calculation's concerned, it's going to total everything up and throw it down here into the line currents. But if you do exceed these particular ratings, you'll see that the outlets get warned, so you can move things around accordingly. Over here on the side, you have the current by breaker, and you'll see that this is lower than the line currents because these are double pole breakers that have the L1, L2 line pairs, etc. So you'll see these two charts should match up, 10.6, 10.6, etc., etc. And then what we're actually going to be talking about mostly today is this phase balance. So this chart down here, and this particular value is how far away from the average a particular phase is. So in a perfectly balanced system, these will be 100%. And then your deviation outside of that is what we're concerned about, is how far away, how far below or how far above are you from the average. So you can use this tool. Obviously, at this point, if you're working remote, you may not be planning new rack builds, and you may, they're already deployed. But if you're going to add a new server or a new switch into your cabinet, you can use this tool to kind of plug in the data that you have existing. And then, if you're going to duplicate this Exchange server, for instance, and add another one, you can just, plug in another value and see what effect that has on your three phases. And obviously, adding it to L1, L2 here, you can see that brought us closer to being balanced. So, you all understand the risks of having, unbalanced power and stranded power. Obviously, you're, operating inefficiently if you're unbalanced, but you're also putting yourself at risk because you could potentially have a failure at the rack level. Maybe your floor PDU, you trip a breaker or something, and that would obviously result in some big problems for you, especially if you're overloading a single PDU and then it fails over to your B side and it then trips a breaker on your B PDU as well. So yeah, it's not a position that you want to be in. So that's one way that you can kind of provision stuff and make plans to deploy new servers, switches, whatever equipment you're using in your cabinets. Use this as a tool for you. We obviously provide many different PDU capacities, and if you have some specific needs, reach out to us. We'll see what we can do to help you. This tool was built by our engineering and product management teams, so we can make changes to it as needed. Yeah, just give us a shout if you need some help. Next, we're going to jump into the web UI of a Raritan PDU and look at how we can view that in the PDU itself. So we're at our PDU dashboard. The home page of the PDU is, you'll remember from last week if you were with us. Up here we have inlet data. So you can see our three phases. There's not a tremendous load in this PDU because it's just a demo. But In this section here, you'll see unbalanced current. You'll see that it's at 33%. So when you're dealing with a small load like that, a minute deviation is going to result in a big percentage. Obviously, it's easy to get unbalanced when you're running pretty low amperage. So what we can do is go into Inlet here, and then if we scroll down to the very bottom of the page, you'll see a threshold section. So we can click on this. By default, this inlet unbalanced current threshold is not set up. But if we highlight the line and then click on Edit Thresholds, we can actually go in and select an upper warning and an upper critical level. And these default values of 5 and 10% may or may not be appropriate for you. You have to kind of gauge that based on any historical data that you have and how you're running your cabinets in the data center. So if I go ahead and save this, you'll see obviously since we were at 33%, this automatically goes into the above upper critical state. And last week we set up SNMP traps and we set up SMTP email alerts. So by enabling these thresholds, it now has something to trigger off of. So we would be getting an email for this unbalanced current above upper critical. And in the real world, this is useful for you because if you are a remote employee managing a remote data center and you have a local team that is adding servers or moving things around, you can see the effects of what they're doing and get alerts off of that. Maybe you told them to plug in this Cisco switch into outlet 28, but they plugged into 29, which is on a different phase. You'll see what happens after they do that, and you'll see that you're now way more out of balance than you expected based on your calculations. So the other thing that I want to point out here is you'll notice that the unbalanced current value here it looks a little bit different from what we were seeing in the calculator. So this is 33%, but this is 103%. So these calculations are slightly different. I'll show you the PDU calculation. That's actually on our help page. So if you go to help.raritan.com, you select your PDU series, whether it's 3K, 4K, 5K, or 1K, 2K. You can go into the help menu, and then down on the left-hand side, we've got additional PX3 information. In this menu, you'll see an unbalanced current calculation. So this gives you the details of how we're calculating that. And we are taking the average current, so taking the 3 phases and dividing it by 3. And then we'll look at the L1 minus the average current divided by the average current. After we do that to all 3 phases, we then take the maximum of the absolute value of those. So it could be a negative value, which is why it's important that we're looking for the absolute value, because the phase that's most out of balance may just have less on it. And the other 2 that are higher in current are actually more balanced. So we take the absolute value, we look at the maximum of that, and then we multiply it by 100 to convert it to a percentage, of course. And then here's an example of that. So the average of these 3 currents is 4.9 amps. And then our current unbalanced for L1 after the calculation above turns out to be 0.12, 0.06, and then the very last one's a negative 0.18. So after we take the absolute value, our greatest value is now that 0.18, which gives us our 18% current unbalance. So basically, in the Excel sheet, in the calculator here, we're just not doing that subtraction. So, what you would see in this case would be 133%. What we're seeing in the web UI of the PDU, 33% would actually be 133% here because it's, 33% above the average, or it could be 67% if it was 33% below the average. So that is, in a nutshell, a couple of the tools that we offer to help you with balancing the phases and also setting up alerts to see if your phases are unbalanced, based on parameters that you have set. So at this point, I'm going to pass it back to Joel. We will open it up for some questions and yeah, see how you guys are doing. Joel?
Okay, great. Thank you. Thank you, Duncan. That was excellent. So we're going to unmute everybody and give you the opportunity to ask some questions here.
Joel, just wanted to remind everybody that this session, both the Q&A and the live demo, is being recorded.
Okay, okay, good. Can you unmute folks, Javi?
Yep, everybody's unmuted, and they may want to check their own side to make sure their unmute button is on as well.
Right, right. And while we wait for questions, there's Duncan, while you were going through this, is there any guidance available for let's say a facilities team for when they are connecting servers to the PDU for load phases? Is there any guidance that we generally provide?
Yeah, so on the physical PDU itself, depending on how many circuit breakers and outlet groups it has, there will be markings on the PDU. And let me pull up the mechanical diagram here. So this is the demo PDU that we were just looking at, and zoom out a little bit here. So you can see that we've got the 3 outlet groups, and we zoom into where the circuit breaker is, we can see this is on the L1, L2 phase. As we go across, we'll see this one's on the L2, L3 phase, and then circuit 3 is the L3, L1. So, that's a quick way to, view it physically on the PDU and just make sure you're plugging it into the right phase.
Okay, great, thank you. Let's see, do we have any questions from anybody on the line? If not, I'm gonna start asking Javahar questions about his shirt.
You can always ask that, Joel. But I do have a question. I do have 2 questions on the line, on the chat. So the first one says, what do you consider too unbalanced? Would it be 5%, 10%, or more? And
So that's a good question.
Yeah, Duncan, go ahead.
Yeah, I was just going to mention that, we were kind of discussing that, before this whole webinar, and it's really dependent on, how you are loading your racks. I mean, if you are, obviously 30% is too much, but on this PDU, there's not much of a load on it, so you can't really avoid it in that case. Now, if you are closer to capacity, that 5 and 10% value is going to be a lot more realistic. So that's why we plug those default values in, because we're expecting this PDU to be utilized fully. So those are good guidelines, but you really have to go off the historical data that you have in your data center, for how you manage it.
Yeah, one of the things that I would add to that is to look at why we care about having the phases balanced in the first place, right? So if you have 10% variance between the phases, so it simply means you are leaving that 10% capacity stranded. It's not being consumed. It's not being utilized. So that's the key on one front. And then the other trickle effect that it's going to have upstream. So if you have a row full of PDUs with the same 10%, that quickly snowballs into something bigger. And that's a lot of stranded capacity and also a lot of stress on the other 2 lines that we're putting on this. And that's one way to look at it. And the thresholds would be very much dependent on your risk tolerance and also how you have loaded the rack, as Duncan said. So if you're like in an 8.6 kVA PDU, if you're loading it really close to the max, then you cannot afford to have a lot of imbalance there. So you would need to have the threshold much lower. Whereas if you are, let's say, 30 to 40% of the capacity of the PDU, then perhaps you can have a a little bit more of a lenient threshold there. And hope that helps. And
Yeah.
if others on the call have any best practices or guidance that you would like to share based on your experience, that'll be great as well.
Yeah, and Duncan, just to add, there is in the PDU web UI a way we could look at recent changes in the unbalanced current trends. Let's say when a device is added to the PDU as well. I don't know if we can show that, but we can certainly do that as well.
Yeah, so you mentioned trending. So we have this trend chart here in the inlet history. Right now, the selected sensor is active power. We can actually go through and we can select unbalanced current, and we can look at the changes over time. And you can obviously see not huge spikes on this particular demo PDU, but you can go through and look at this historical data. And the way that these data points are determined is actually in the device settings page under data logging. So this particular demo PDU has measurements per log entry of 600. And what that means, every sensor on the PDU is polled and measured every second. So this basically means that we're taking 600 seconds and waiting to log that 600 measurement. So there's 10 minutes in between each data point in that chart. Now, we can adjust this anywhere from 1 to 600. 600 is the max, depending on how granular you need the data to be. I believe the default for our PDUs is 60. So by doing that, we would get data logging every minute, which is pretty acceptable in most cases. If you need anything more granular than that, you can of course go down, or maybe you want it every 5 minutes. You can set that to 300, and that is totally independent of what your SNMP manager might be doing. Your SNMP manager may only be pulling the device every 5 minutes, depending on how you have that set up. But this determines, the stored values in the PDU itself, and we store 120 measurements. So that's where this whole chart comes from. If we look at the inlet again, this is 120 measurements worth of 10-minute readings. So yeah, that can fluctuate however you need it to.
Okay, great. Thank you. Thanks, Duncan. And we'll see if we have any more questions. Do we have any more questions on chat, Javi?
Yeah, I do see one more. The question is, a couple of my PX3 ATS PDU are reporting out of sync feeds. Can you explain how we might fix those? My belief is this is just on the ATS, or the what we call the transfer switch part of it. That's the only product that I'm aware of that needs the two feeds that are coming in, A and B, to be in sync. And if they are out of sync, then you cannot guarantee transfer. And that's perhaps the background of that question. Let's see if so Duncan, are you aware of it? If anybody else on the line that could field that question?
Yeah, so Jawahar, you're absolutely right. That is the only product that reports that, and you're also right, and that it determines if it's going to transfer. But there are settings that can be adjusted. So I'm just going to look at our help documentation here and show where that documentation is. But if it is out of sync by a certain degree, then it's not going to want to transfer based on it not being safe. You can force it to transfer no matter what, and that's a setting that you can look at within the PDU itself.
Yeah, and Duncan, this is Kamal, and I might add that how do you fix it? Basically, that's just an informational screen. So generally, it tells you that it's wired between different phases, and to fix it, your source for both feeds has to be on the same feed, basically. same phase, I would say. And there are some settings that you can do. So the transfer would occur, but retransfer back is by default disabled. And I think Duncan is finding that configuration option that you can override. So retransfer might occur after the power has returned.
And maybe this is a question that we can definitely work with you offline if we need to do a remote session and help with that setup and configuration. We can certainly do that. Hopefully, Javi, we captured the contact or the customer that asked that question. We could reach out to you following this call to make sure that we have the setup correctly.
Yep.
This is Bruce here. Can you hear me?
Yes, Bruce.
Yes.
Yeah, I can add a little bit something to that. For most part, being able to synchronize the sources is a matter of the upstream equipment in the facility. Ultimately, it's done at the UPS level. That is, you need to have UPS systems that contain a feature generally known as sync bus. I think Liebert uses that term, parallel bus. Effectively, it's technology at the floor level UPS stage where the UPSs share oscillator information between their inverter circuits. So they are independent with respect to the line currents and voltage, but they are sharing oscillator information for their inverters for the purpose of then synchronizing the line 1, 2, and 3 outputs of otherwise independent UPSs. So it does involve a bit of upstream investigation. The PDU is simply reporting that it is presently not synchronized.
Great, thank you, thank you, Bruce.
Helps.
Thank you, Kamal.
Yeah, Bruce, thank
Bruce,
you so much.
that's great
And I think,
information.
I'm sorry, one of the things that I wanted to just make sure everybody on the call is clear is that this is just for the transfer switch products under the PX3 line. This does not apply to standard PDUs.
Right. Okay, do we have any other questions, either in chat or if anybody would like to ask? Well, we're fully loaded with all of our tech experts here. Okay.
Well, if anybody has any suggestions for future topics, please let us know either on the chat window or by just letting us know here.
Great.
And if we don't have anything else, then we can wrap this up. Joel?
Yes. So once again, thank you for joining us for our second session. We'll have our third session coming up next Wednesday for the Raritan brand, and Thursday and tomorrow for the ServerTech brand, and also next Thursday for the ServerTech brand as well. So Wednesdays and Thursdays for the Raritan brand, ServerTech brand, and we'll continue to bring you more tips, more live Q&A, and hopefully we could continue to help you and support you during these times. And thank you guys all for joining. Thank you, Duncan. Thank you, Javi, and all the Raritan experts on the phone. Thank you.
Thanks, everybody. Take care.